Okay, hello everyone. Welcome to the session on designing a college campus today. If you're new or an intermediate engineer curious about how to piece together a secure and a scalable infrastructure, you're at the right place. Today we're going to explore an example scenario where you have a campus with two buildings, various departments. Let's look at some of the best practices for routing, addressing, and more. Let's dive right in. Before we dive into network design, this is a pretty straightforward, I would say, diagram that illustrates how to find the right solution. That solution that's the diamond in the middle is always the hardest thing to find. We're going to design a network here, and if you look at it, network is carrying the business. Now, business is the car that drives on that road. The tires are the apps that you have because apps are really running businesses and businesses are running on the networks. Pretty much safe to say your business today is as efficient as your network is. First thing is you want to start gathering information about that particular business. You gather all the requirements, look at the basic fundamentals, things like your IP addressing, bandwidth, latency, throughput. Where are those sources? Where are those destination? Those are your fundamentals. You need to understand those. Once you understand all the fundamentals, then you apply different technologies, switching, routing, firewall, different protocols, routing protocols, spanning tree protocol, Ether channel, HSRP, VRRP. That's where you build a solid foundational network. Now, let's look at this example. And as I said, this was one of the examples I come across when this is an assignment given to students and people are just, let's put something together and start configuring into Packet Tracer or EV Engine. Before you start doing that, I think it's very important to understand what are you trying to get out of that network. If you look into this, it's basically your task as an engineer to design a network infrastructure for a college. Now, the network should be efficient, secure, scalable, usual stuff, giving you some details on, okay, how many students we have, some admin people there, there's about IT people, finance, and then library, it just says everyone has access to Wi-Fi connectivity. Now, there are some holes in this question, I'll be very honest, when I started, but I didn't want to change it too much. I just wanted to say that if you get less information from your customer, then what are the things that you need to poke your customers about to get the requirement? Because that is part of your job as well. If you look at this, they're just saying, okay, understanding the campus layout would be, we have two campuses, A and B, each is hosting different departments. Campus A, for example, contains IT, admin, data center. Campus B has finance, student, classrooms, and then library. Library provides Wi-Fi for everyone on the campus. We must ensure reliability, connectivity, and making sure security is there as well. There are printers, talking about data center. So this is your campus A. I've broken it down. So when you get a very high level understanding of a network, best thing to do is to go ahead and actually put a diagram together, which could not be your final result, but just pen on paper to get what exactly this is. What are the components that you'll need? Obviously, you'll need routers because they need to manage traffic between campus A and B, as well as external networks via the data center. Switches will connect departments like IT, finance, students, and library. And data center is pretty much sitting in campus A, which is not really a data center. Think of this as a main closet with probably running a couple of servers that's been named as data center, right? And then you have some printers that are being shared. That doesn't matter where you are, as long as you're within the campus, you should be able to print to it, but not outside. Straightforward. All right. So when I looked at all this, this was the first diagram that I just created, thinking, okay, this is my information that I have so far, right? For example, campus A has a router, has three departments. Each department has its own switch. Just did that. It's connecting, uplinking to another extranet router that has access to internet. And then campus B is also similarly with different departments, but connected to that extranet. And then you have some services like D2L, which is usually a learning management system, which usually students would go log in and see what assignments have been given. And teachers, that's the platform they interact on basically, right? At this point, I have this information. If on Packet Tracer or EVNG, should I just dropping those routers and switches and start configuring? Do I need anything else? That's the question here, right? Now, first of all, you have to understand, do I have the full information or am I missing something here? And I think there are few things that are unclear. They never mentioned what's in the DC. The Wi-Fi architecture was not defined. I won't go into Wi-Fi architecture in this one because that's a whole different discussion right now. And how far are these two campuses? Because if they are, let's say, 300 feet apart, I can figure out a way to connect them. I don't need to have separate internets. I can just somehow run this cable, obviously a fiber in this case, if I'm wiring it, or I can use a wireless bridge in this case. But then it comes with its own challenge. Yes, it's easy. Deployment is going to be much more easier if I'm using a Wi-Fi link. But let's think about this as from a perspective of, doesn't matter if you end up using a Wi-Fi link or maybe you run a fiber cable and you still have a wireless as a backup there. Think of this as a cable. Somebody's taken this cable here and it's connected there. If these campuses are 30 kilometers away, then obviously I'll have to have a different approach, right? One option would be I have another internet at that site and then I create some sort of VPN between these two sites. So they still look like they're one. Or I can go to an ISP and say, can you please give me a private link and connect these two devices? And again, you have different options there. You could use MPLS, layer 3, layer 2. You can use EI, wavelength, or options that your ISP is able to provide. Now, something that's not clear is what's in the DC really. And these are some questions that I had in mind when I was looking. I thought, let's look at one of the campuses that I have that's close to my house where I live. And I looked at that. The local college that I have closest to my house was about, these were the two buildings actually they had, funny enough. So I thought, okay, let's use that as a use case. And when I go to Google, Google has an option where I can go right click, measure distance, and I can really measure distance here. It came to me that it's about, say, okay, 230 feet. So give or take 300 feet. I'm not too sure if this building is 2-story or 3-story. I didn't get a chance to look at it. If in one of the cases, the switch could be on the top floor, the other building, it could be in the basement, so the run might get longer. But the long story short, 400 feet, I can get this up and running, right? I want to connect using what? As I said, fiber, single mode, multi-mode. Generally, I would say there will be multi-mode here. Yes, how many strands I want to run, that's another question there. If you're doing a physical run with a multi-mode, you might as well run some extra strands there in case something get cut, you still have some other option. If you figure out that I need 4 strands, now what's a strand in the fiber? It's you need 2 at least for one connection. One is your receiver, one is your transmitter. For one connection, you need at least 2, right? So if you're thinking of connecting 2 ports, then I need 4. Okay, so just giving you that heads up there. Perfect. So that's done. What's the next thing you want to look into that? Now, in this network, it also, I would ask questions like, in this case, this was your existing building and you just bought this one. Now you want to extend your network here. Is that the case? So is that a greenfield or a brownfield? Brownfield means there is already something in there, which means it's an existing network, it's an extension or making a change. Greenfield means I've just acquired these two buildings, come here and put the network. That's an important thing to understand. Where are the users? Where is the destination? Right? Now think about if you're trying to build a new city, if you're an architect building city, network engineers are thinking of roads going from A to B. Now, if a person wants to go to A to B and you make a road from A to C, that is not helpful. That's where you need to understand where are the end users and where are the destinations, right? For example, in this case, students are going to the LMS system. Now, is this LMS system hosted in the cloud or is it hosted locally in the data center? Different thing, right? So what about DHCP? Now, DHCP, if you look at the diagram that we had before, now DHCP is not available maybe in one of the campuses because I'm putting the DHCP server in the main campus, campus A. How would campus B people get DHCP? Now, why do I need DHCP? Because obviously I'm not going to go give a static IP address to all the students. It's not going to be possible, right? So people are bringing their own laptops, maybe connecting to Wi-Fi. It has to give out or plugging in their laptops into certain ports that provided them. They have to get a DHCP. Now, you don't want DHCP on individual switches, which is possible. Switches can give out DHCP, but then that central management is not there. So you want to have it as a separate server so you can have that there. Make sense? All right, so let's look at this setup now. A student laptop comes in, it sends a DHCP discover. The router or the layer 3 switch in this case, which is most common, uses an IP helper, which I'll show you, actually sends a unicast to the data center and then basically gets an offer back. Laptop receives that IP config and then you're up and running and you can go from there. Now, diagram will make this thing more clear. So for example, student is in VLAN 10, right? On this router or layer 3 switch, I will create an IP helper address where I'm saying that, okay, you're part of this, but IP helper address is on VLAN 100, which is right here, which is my DC. Unicast comes all the way from here, and this is what it responds back. As I said, the reason I want to do that is because I want to have a centralized DHCP for all my different pools. So all the pools, IT, admin, uh, finance, students, and library will be created here. Now, there are certain things in data center. I have servers, they have to be statically programmed. Now, another thing is when DHCP is hosted in the data center or my main rack, should I do use like a physical hardware or should I use like virtualization? Now, pros and cons. If you have one single that's a single point of failure, or you need to have two servers and then try to sync, or I can have a virtualization system like a EXXI where I have two servers and I can have these two different VMs, which are actually the Windows server that is doing my, say, Active Directory or even DNS or DHCP. And if one of them fails, it automatically just moves there. Now, that's something that is, we won't talk about this in this particular video, but that's something that virtualization has been doing it for a long time now, right? Where you're able to have two copies. And if the whole idea of that is now, this is where cloud is really based on, right? That's why cloud is considered. If I put something there, it's the cloud's virtualization that manages that in case my particular virtual machine that I've created fails, they move it to somewhere else or region wise also, right? So that's just how it keeps it safe. But point here is that I need to understand where my DHCP server is going to be hosted here, physical, virtual. And the next question becomes is, before I start configuring routers and switches, we need to also understand with the IP addressing. So what kind of IP addressing am I going to use? Obviously, looking at the size, IT, I like to keep it clean. A lot of people say, yeah, you can subnet is small. See, this is going to be all internal, which means you're going to be using a private range. If you're using a private range, my option or for troubleshooting, it's always easy to use a /24 in my opinion. That's what I have always used, and I've seen a lot of, you know, people who have mentored me suggest me the same thing. Again, I'm just going to try to match it. So 10.10 is my standard. This 10, 20, 30, 40, 50, they represent basically all the VLANs that are matching to that. Now, the only VLAN that needs /23 will be students. The reason that is because I want to have more than 350 IPs, right? Now, if I have /24, it's only 254. That's all I get. That's why I need a /23. Now, since it doesn't break, I could have also done 1, 2, 3, 4, 5, and 10. But the reason I picked up 10, 20 is because there is gap between these. So when I do a 40 and I do a /23, it means I'm going from 40.1 to 41.254. These are my 512 IPs that I'm able to use now. And on this screenshot that you see is from this website, which is a great tool for your subnetting, which is your HTTPS CIDR.xyz, right? So again, understand if there is a new or an existing subnetting already there, like if there's already a subnet in place, then you'll have to make sure that you're aligned with that. You can't just overlap IP addresses. If it's already been used, you need to work with the same range. If it's not used, life is much easier that way, right? Perfect. One more thing I want to talk about is this assignment talks about routers. What does a router do? Why do I need a router? And how does a router do what it does? So first of all, why do I need routers is if I have two different networks and they need to talk to each other, I need a router or a layer 3 device that can map you from one LAN to another LAN. How does router do it? Is it uses something called as default gateway or next hop, which means once you come in, once you enter, this person or this packet is entered from here. If you're coming from A and you want to go to B, C, or D, you'll take this connection. And this is all stored in that routing table. It forwards packets from one interface to another. It has something called as default gateway and next hop. I have a video, I think, on which I have covered that already. Now, what makes this happen? See, routing table makes that happen. Router has a control plane, which is where the routing table lives, where you have the best path for each prefix. What's the next hop? Which exit network interface should I take here? Now, how can I configure it? I can do it statically, manually. Somebody sits and types it in. If you want to go here, pretty much like programming a router. Or I can use the dynamic routing protocol, which is EIGRP, OSPF. The ones are the common ones that usually get used in the LAN side of things, where automatically that if there are two routers are there, they exchange routes, they figure out okay, I know about this, you know about this. Okay, so now we both know about everything that's in the area. If there are three, then they all exchange routes the similar way. Data plane is, now one more thing I want to quickly touch upon here is inside a route, think of that as they have two people in there. One is the rib, which is think of the guy with a sheet that has all the routes, which is your control plane. And then you have a fib, which is the forwarding base, which is information base, which is think of the guy with a gun, which is shooting packets out fast. It's ASIC based fast forwarding. The idea here is you're able to fast deliver these packets. They are fully resolved routes, and all information is there to create a layer 2 header. Because don't forget that if I'm going from here to here next segment, in order to send that packet out, I also need the MAC. I need a MAC of the leaving and also the MAC of the going interface. Think of them as a teamwork. One is the control plane, other one is the data plane. One is responsible for knowing where to go, other one quickly forwards it. These are the two people sitting inside your router and making it all happen. Now I have a slide here which talks about a bit more. I won't read through it. You can pause the video and look through it. Now the next question you want to answer is, do I really need to have static or should I use dynamic? Now in this case, if I was doing it, I would just do it a static, which means each can have a manual route. Now you must be thinking, is I have three here and three there on the other side. I need to manually tell them each one to go somewhere. Instead of doing that, I can summarize them together and say, all of you go that way. When somebody coming from campus B wants to come to A, all of you come this way, right? So let me show that in a diagram here. If you have a campus A, I'm just using a /18 subnet, but you could have done even with a /20, I think would go. Basically what I'm saying is these are the two basic static routes, which I'm saying is anybody from campus A static route, which means 10.10.64 who falls under here, you go that side. And then on this side, all of you guys coming, you come back. Now, obviously, the subnetting that I use has to change. All the subnetting on campus A should be in this, within this network, and within campus B should be within this network. 60 onwards you can use from here. 60, 70, 80 would you use there. 10, 20, 30, 40, 50. That also gives me room from growth as well. That's the reason I use /18. If you add a couple more VLANs, my scheme stays the same. It doesn't break it, right? How does it work? A campus A uses a /18 block, for example. This will cover all the IPs up to this, and it will send it across that way. This is what I can use. And similarly, campus B. Configuration is pretty simple. I'm not going to go over the configuration. And the connection between the two routers, I can just use a /30 if I want, or I could even use a /24. Nobody's stopping by doing that, but /30, why? Because I only need two IPs, right? I'm connecting from one point to another. That's about it here. All right. So this is again telling you the exact summarization. If you can use summarization route because you only need one route really. I don't need to put like multiple routes. The static route becomes a problem when you have to do multiple routes. But if I'm just saying campus A, everybody point that side. So I'll really need only two routes. One would be if I want to send something locally that's on the campus B side, I say, okay, campus A, you go on that side. And for campus B, you come on this side. And anything that has to go to the internet is a default route, which is anything is not included. That's where the 0.0.0.0, you can go outside to the internet to get to everything outside. That's pretty much what that looks like. Now, we've solved the problem here. This is what our design is. Now I have a design, I have a configuration. Do you see still a problem with the design? I see one, which is a single point of failure. Single point of failure is like only having one link to one router or no backups to the entire network. Or if one of the devices go down, pretty much can bring the whole network down. So there are more, but let me see what are the problems. One, obviously you only have one internet. If the internet is down, anything on the internet, like if the module or any of the LMS systems, Blackboard were hosted onto the cloud, you can't reach it. If this router dies, guess what? The whole campus down here, whole campus down here. Similarly, if 3 is down, I will still have this campus down because don't forget DC has the DHCP server. So nobody will get any IPs, nobody can still communicate. This link is a problem. This link goes down, this brings the whole system down. So these are the quick points that where I saw that, okay, if these 6 points go down, it can bring your network down. These are your single point of failure. We need to think of some sort of backup, right? But before we do that, we also need to figure out what devices will I need. So where would I need a firewall? For example, if I'm saying this should be a firewall, okay, which vendor you're going to go with. Are you going to go with Cisco, Aruba, Fortinet? If yes, then you need to get two of those because I also need to have them in an HA where they're active or an active standby, depending on what kind of config you're looking at. Similarly, if it's a layer 3 switch, I need two of them. Are you going to use different technologies to make them act as one? And if I'm picking up this particular device, then I obviously, because I'm plugging in some devices that might need power over Ethernet, so you need to consider that part. That's how you pick up the devices. Once you pick the devices, then you pretty much try to make your design more redundant. I'll have two internet connections, then I know that, for example, if one internet fails, I have a second provider going on there. Uh, Two firewalls, they will be doing NAT, ACLs, the policies which are restricting people from going where they want or who which can talk to who, depending on what policy is the network or the business asking for. You will have two layer 3 devices, right? This is where you'll create your SVIs. Now, this is a dotted line, and have you seen me draw this before in the other videos? It's pretty much like anything above this is layer 3 interface IP, anything below is your layer 2 interface. I don't need a spanning tree, but if I had this switch with multiple VLANs, then I would need a spanning tree because then I'll be creating loops. But since it's only one switch hanging off here, it's the VLAN one is only, so that's the root, this is the down, there is no loop happening. Technically no STP, but still you can leave it on just in case somebody takes a cable, plugs in from here to here, and you just created a loop. So always good to leave it on, but obviously you don't need to configure it like from a perspective of load balancing and stuff like that, right? This is where you do your IP helper. And I've also done some sort of ether channel here. So every link will have double links going up. And then I'm also using an ether channel. Point to remember is if you use ether channel, there is no STP requirement because it's a logical interface. It looks it as one. And there you have it, a straightforward approach to design a college campus network infrastructure by understanding a physical layout, choosing the right IP address strategies, setting up the router, VLANs properly, planning obviously potential single point of failure, and that's how you will build a network that is both scalable and reliable. Always remember to keep it simple and gather all your information and requirements from a business upfront. Now, challenge I like to give you is go ahead and design this in Packet Tracer, EVNG, whatever is your choice of tool, and let me know how it goes. Thank you for watching. If you found this helpful, please like the video, share with a friend, or drop a comment below with any questions. Keep learning, stay curious, and happy networking. Bye for now.